All right, so as you can see, students will be identifying some characteristics of rational functions. At this point, we've seen how to add, subtract, multiply, divide, and simplify our rational expressions. Now we're going to be taking a look at their graphs. All right. So first thing you notice is we've got our parent function, 1 over x. This is called a rational parent function. The question is why? Why do we call it rational, and why do we call it the parent? Well, let's take the rational part first. Why is 1 over x called rational? Well, if we go back and think to what a rational number is a fraction. It's the same idea here. A rational refers to a fraction. So the reason we're calling this rational is because it's written as a fraction. But more specifically, because there's an x in the denominator of that fraction. So really we're calling this a rational for two reasons. Reason number one, it's a fraction, but more specifically because there's an x in the denominator of that fraction. So that's what the rational part means. It's a fraction with an x in the denominator. So why do we call it rational parent function? What does the parent part mean? Well, we've seen parent functions before. And when we talk about parent functions, we're talking about the simplest or the most basic of functions. In other words, we're not adding anything, we're not subtracting anything, we're not multiplying by anything. We're looking at the plain Jane function. Nothing fancy to it. Which is what we have here. 1 over x is the parent function for our rational. There's nothing added, nothing subtracted, nothing multiplied. It's the simplest form. So the first thing we're going to start off with today is what does the graph of our rational parent function look like? What does 1 over x look like? Well, we've seen it before. We saw it, I guess the first week of school. But I'm guessing you probably don't remember what it looks like. So we're going to take a look at its graph here. And the way we're going to do that is come up with the graph ourselves. So what I need you guys to do is your calculus. Get your calculators out and get yourself a nice clean screen. Do not go to y equals yet. Hold off on that. Just go get yourself a nice clean screen. Notice we're given a table, and we need to fill out this table. And just like we do with any other function, to get our y values, we're going to take the x's and plug them into the equation, or in our case, 1 over x. Here we go. So we're going to start with negative 10. If I replace this x right here with a negative 10, what do I get? Well, let's find out. Put it in your calculator. What's 1 divided by a negative 10? Negative 0.1. So write that number down on your table. Negative 0.1. Now let's do 1 divided by a negative 5. That's 1 divided by a negative 5. Negative point what? 2. Okay, let's keep going. 1 divided by a negative 2 would be a negative 0.5. Now let's do a negative 1. 1 divided by a negative 1 would be a negative 1. 1 divided by a negative 0.5. 1 divided by negative 0.5 is negative 2. 1 divided by a negative 0.25 would give us a negative 4. 1 divided by 0. 1 divided by 0 is error. Now notice you get an error here. Go ahead and write that down for me. 1 divided by 0 is error. Does anybody know why we're getting an error? Well, it's going to stop on the graph there, but why else? Why would the calculator? What? That's right. You can't divide by 0. You can't divide by 0. All right, so let's keep going here. 1 divided by 0.25. 1 divided by 0.25 is 4. 1 divided by 0.5 would be a 2. You've seen a pattern here, right? 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 5 is 0.2. And the last one, 1 divided by 10 is a 0.1. All right, so here's the table. Now that we have that table of values, we're going to take those values, or those ordered pairs, and we're going to plot them onto our graph paper. Now you'll notice the first one does not fit. The graph paper we have here does not fit, or we can't fit negative 10, negative 0.1 on our graph paper. Okay, so we're going to have to start with the second. So let's graph negative 5, negative 0.2. Let's find that ordered pair. Here's my negative 5, negative 0.2 would be somewhere right around that area. The next one I'm looking for is negative 2, negative 0.5. So here's negative 2, negative 0.5 would be somewhere right about there. Negative 1 is the next ordered pair. Here it is. Negative 0.5, negative 2. Here's negative 0.5. Negative 2 would be right about there. And negative 0.25 and negative 4. Negative 0.25, negative 4 would be right about here. Zero error. Where is zero error on the graph paper? There is no such thing as zero error. Okay, so we're not going to graph anything there. We're going to have a big hole in our graph. So don't worry about plotting zero error. You can't. So let's go on to the next one. 0.254. Let's find that one. Here's my 0.25. Positive 4 would be right about here. 0.5 and 2. 0.5 and 2 would be somewhere right here. 1 is the next ordered pair. 2 and 0.5. Here it is. 5 and 0.2. Right about there. And notice that last one, 10.1, won't fit on our graph paper, so we won't worry about that. So let's go ahead and connect these points and see what kind of graph we get. So I'm going to connect these dots here. Remember, we said we cannot graph zero error, so we've got a little bit of a gap here. There is nothing that we're going to connect. We're going to come back up here to the top and connect these points here. Now notice, guys, when I drew this, I got real close to the x-axis, but I didn't actually touch it. Notice I also got real close to the y-axis and didn't touch it. So make sure when you're drawing yours, you do the same thing, because that is important. Matter of fact, we're going to be talking about that here in a second. So this is what our graph looks like. Does that look familiar to you guys? Remember seeing that at the very beginning of the school year? And we talked about these rational parent functions. Now, within these rational parent functions, you'll notice there's two parts. We got part of the graph over here in the first quadrant, and we got another part of the graph over here in the third quadrant. So there's two parts here. These two parts have something called asymptotes. There's two different asymptotes. You'll notice over here it says we got a horizontal asymptote and a vertical asymptote. So the question is, what the heck is an asymptote? Anybody know what an asymptote is? You ever heard that before? No? All right, so here's what it is. An asymptote is a line, first of all. It's a line that the graph approaches. In other words, it's a line that we're going to get really, really close to. But we never actually touch that line. It's a line that the graph approaches, but we never actually touch. Or we can say the x and y values are becoming extremely large or extremely small, depending on where exactly we're looking on the graph. But we're going to stick to the basic, and we're just going to say that it's a line that our graph approaches. Now notice it says there's two of them. There's a horizontal asymptote, and there's also a vertical asymptote. So the question is, where are they? Where can I find those asymptotes? Where are the lines that we're getting really close to but not actually touching? Well, I kind of pointed those out already. Anybody know where those asymptotes are? What line am I getting really close to but I don't actually touch that line? What? Say that? The x. The x-axis, I think, is what you're trying to say, right? This right here. Notice I'm getting really close to this line here, but I'm not actually touching. Draw yourself a dotted line right over the x-axis, because that right there represents one of the asymptotes. That right there is the horizontal asymptote. That's all right. Just do it as best you can. There is another one. There's another line that we're getting really close to, but don't touch. This one is going straight up and down, vertical. Can you see it? The y-axis. So draw another dotted line. So So these two lines we're getting really, really close to, but we don't actually touch them. We call those asymptotes. All right. So in this case, they are the x-axis and the y-axis. The x-axis and the y-axis represent asymptotes. And the equation for the x-axis is y equals 0. The equation for the y-axis is x equals 0. And we're going to need those equations here in a little while to identify the asymptotes. Now, right now, the asymptotes are the x-axis and y-axis, and that's because we're looking at the parent function. That's not always the case, guys. And eventually, we're going to start moving this graph around, and those asymptotes are going to change. All right, so the next question is, how does this affect the domain and the range? How does this affect the domain and the range? Well, as far as the domain here are all of the x's except for one. There's only one number that we do not include as part of our domain, and that is a 0. Right over here, you'll notice, right here, we're going to say that the domain is all the numbers except for that 0. And the way we write it is x does not equal 0. That's an equal sign with the line through it, saying it's not equal to. And why are we not including 0? Well, what happened when we put a 0 in there? Error. We got an error. So we don't want to include that. The range, the y values, we're going to use all the y values except for one. There's only one y value we don't use. You'll notice we're using all the positive y values here, all the negative y values here. There's only one that we're not using, and that is 0. 0 is the only y value that we do not use. And you can see that in the table as well. Do you see a 0 up here in the table? No. All right, so again, these are the domain and range. Everything except for 0 for the x, everything except for 0 on the y. Now again, this is only for our parent function. That will be changing here in a little while. All right, down at the bottom, you're given 3 graphs here. They want us to do a couple of things. The first thing they want us to do is draw the asymptotes. So let me go ahead and draw the asymptotes for this first one. There's 2 lines that we're going to get really close to, but we don't actually touch. I'm going to start with the horizontal asymptote, and that's going to be this line right here. We're getting really close to this x-axis, but we don't actually touch it. So I want you to draw yourself a dotted line to show that asymptote. Matter of fact, I'm going to write the equation for this line that I've just drawn here. And the equation for that line is y equals 0. That's the equation for this line right here. But there's another asymptote. There's a vertical asymptote. There's a line that goes straight up and down that we're going to get really close to, but we don't actually touch it. Can you see it? Where do I need to draw my vertical line? There it is. When you draw it right here. This is the other line that we're going to get really close to, but don't actually touch. And the equation for that line right there is x equals 2. That's the equation of that line. So these 2 lines represent my asymptotes. Now along with that, they also ask us to take the domain. What are the x values? So out here to the side, I'm going to write down my domain. Now, the domain is all of the x's except for one number. There's one number I do not include as part of my domain. Can you see what that x value is? Nope. 2. Notice if I look right here, starting right here at the asymptote, I'm using all of these x values to the left. If I start at my vertical asymptote here, I'm using all these x values to the right. The only one that I'm not using is the one right at the 2 itself. Okay, so x does not equal 2. Everything else is included as far as the domain. Let's try another one. Second graph. Again, there's 2 different asymptotes. There's a horizontal asymptote and a vertical asymptote. Horizontal asymptote is going to be this line right here. This is the line that we're getting really close to. So what's the equation of that line? y equals 2. Y equals 2 is the equation of that horizontal asymptote. There's another asymptote. There's a vertical one, one that goes up and down. Can you see it? Where is it? It's at the close, not at 1, but -1. It's this line right here. So draw it for me. That's the line we're getting really close to, but don't touch it. And what's the equation of that line that I've just drawn there? X equals a -1. So those are the two asymptotes. Now we're going to come out to the side and state the domain. The domain is all the x values except for one. There's only one x value that I'm not going to use. Can you spot it? What is it? Nope.
-1.
There it is. It's -1. Notice, again, if I start at my asymptote, my vertical asymptote, all these x values to the left are being used. All the x values to the right of that asymptote is being used. The only one that's not being used is where that asymptote occurs, which is -1. There's one more. You do this one on your own. Go ahead and draw me your two asymptotes. Give me your equations for those two asymptotes. And then give me the domain. So do those three things for me. All right, I'm going to call somebody up here to draw me the asymptotes, so be ready, and then I'll ask somebody else to give me the equations for those two asymptotes, and then I'll get a third person up here to give me the domain for this graph. All right, so let's start with the graph of the two asymptotes. I want to see where do the dotted lines go. So let's start there. Garrett, come on up here and draw me the two lines. All I need you to do is draw the lines. We'll have somebody else. Yeah, the little dotted line. Where are we going to put those dotted lines? All right, very good. This one is the horizontal asymptote. That's the first one. And where's that second? Where's the vertical? You got it. There it is. And that is correct. All right, so now let's get somebody else up here to give me the equations of those two lines that he's just drawn. All right, so let's get, okay, come on up here and give me the equations. Let's start with the horizontal. What is the equation of the horizontal? We're looking at this one right here. What's the equation of that line? All right, very good. Y equals -2. All we need is the vertical one now. And the equation for that one is x equals a +3. You got it. Perfect. Okay, all we're lacking now is the domain. That's what we need now. So, Samantha, come on up here and give us the domain. Okay. We already know that the domain is all the x's except for one number. So let's see. Can you tell me what that one number is? X is all real numbers except for which one? So write that number down for me. There it is. So our domain is everything except for the 3. Y'all notice a pattern here? Y'all notice anything about our domain and our vertical asymptote? They're the same. Notice the 3 and this 3 are the same number. Did it happen on all of them? Let's check the other ones. Look at what our domain was over here. Look at what our vertical asymptote was here. -1. Let's check that first one. Notice what our domain was. Notice what our vertical asymptote is. So you can tell what your domain is. You can tell what number we're not going to include by simply looking at your vertical asymptote. That's all you got to do to find your domain. All right, so that takes us through the parent function.